Prior to the 1993 National Electrical Code, the standard voltage for lighting circuits was 115 volts. In 1993, the National Electrical Code recognized the increasing use of 120 volt circuits and adopted this as the standard voltage. Article 210 covers branch circuits. In the 2014 National Electrical Code, Section 210.6 listed 120 volts as the nominal voltage for branch circuits supplying lighting and receptacle outlets. However, Section 210.8 referred to 125 volts, nominal. This was not a mistake but reflected a historical practice. In practice, there is no significant difference between 120 volts and 125 volts. Most appliances and lighting fixtures are designed to operate within a range that includes both voltages. The use of both 120 volts and 125 volts in the code is more a nod to historical precedent than a practical distinction. There are a few reasons for maintaining the 125 volts reference. Firstly, some older equipment may still be rated for 125 volts. Maintaining the reference to 125 volts ensures compatibility. Secondly, as technology advances, new devices may emerge that operate at higher voltages. Leaving the 125 volts reference open allows for future growth and innovation. The use of both 120 volts and 125 volts in Article 210 is not sloppy but rather a deliberate choice to accommodate both historical and potential future requirements. It does not create loopholes or diminish safety. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for safe electrical installations. It's updated every 3 years to keep pace with technological advancements and evolving safety concerns. Understanding the NEC is crucial for electricians, engineers, and anyone involved in electrical work. One of the areas that sometimes causes confusion is the specification of voltage levels, particularly the use of both 120 volts and 125 volts in various articles. To fully grasp the rationale behind these seemingly inconsistent voltage references, it's important to delve into the historical context and practical implications. Before 1993, the standard voltage for lighting circuits in North America was 115 volts. This was the voltage level commonly supplied to residential and commercial buildings. However, as electrical systems evolved and the demand for more power increased, the industry gradually shifted towards higher voltage levels. In 1993, the NEC officially recognized the growing adoption of 120-volt circuits and incorporated this as the new standard voltage. This change reflected the need for greater efficiency and capacity in electrical distribution systems. Article 210 of the NEC is dedicated to branch circuits, which are the circuits that extend from the final overcurrent device to the outlets and equipment they supply. In the 2014 NEC Section 210.6 explicitly stated 120 volts as the nominal voltage for branch circuits that supply lighting and receptacle outlets in dwellings. This section aimed to provide clarity and consistency in the application of voltage standards. However, Section 210.8a, which deals with ground fault circuit interrupter, or GFCI, protection for personnel, referred to 125 volts, nominal. This discrepancy might appear confusing at first glance, but it wasn't an oversight or mistake. Instead, it reflected a deliberate decision to acknowledge historical practices and accommodate a range of voltage levels commonly encountered in the field. In reality, the difference between 120 volts and 125 volts is minimal from a practical standpoint. Most appliances, lighting fixtures, and other electrical equipment are designed to operate safely and effectively within a voltage range that encompasses both values. Manufacturers typically account for slight voltage fluctuations and variations in their product designs. The inclusion of both 120 volts and 125 volts in the NEC serves as a recognition of this inherent tolerance in electrical equipment. It also acknowledges the presence of older installations and legacy equipment that may have been designed for the slightly higher voltage level. By maintaining the reference to 125 volts, the NEC ensures compatibility with these existing systems and avoids the need for costly and disruptive replacements. There are several valid reasons for retaining the 125 volts reference in certain sections of the NEC. Firstly, as mentioned earlier, some older equipment may still be rated for 125 volts. This equipment might include vintage appliances, specialized lighting fixtures, or industrial machinery. By allowing for the use of 125 volts in specific applications, the NEC ensures that these devices can continue to be operated safely and effectively without requiring extensive modifications or upgrades. Secondly, maintaining the 125 volts reference provides a degree of future-proofing for electrical installations. As technology continues to advance, new devices and systems may emerge that operate at slightly higher voltage levels. By keeping the 125 volts option open, the NEC allows for the integration of these future technologies without necessitating major revisions to the code. This forward-looking approach helps to ensure that electrical systems can adapt to changing needs and remain compatible with emerging innovations. Thirdly, the inclusion of 125 volts acknowledges the potential for voltage fluctuations and variations in electrical distribution systems. While the nominal voltage is specified as 120 volts, the actual voltage at a particular outlet or device may vary slightly due to factors such as line losses, transformer taps, and load imbalances. By allowing for a tolerance of up to 125 volts, the NEC provides a safety margin that accommodates these real-world variations and prevents equipment from being subjected to excessive voltage stress. Some might argue that the use of both 120 volts and 125 volts in Article 210 creates loopholes or introduces ambiguity into the NEC. However, this is not the case. The code clearly defines the specific situations in which each voltage level applies, and it provides guidance on how to ensure safe and compliant installations. The dual voltage reference does not diminish safety or create opportunities for misinterpretation. Instead, it reflects a pragmatic approach that balances historical considerations, practical realities, and future possibilities. The NEC is not intended to be a rigid and inflexible set of rules. It's designed to be a living document that adapts to the evolving needs of the electrical industry while maintaining a strong focus on safety. The inclusion of both 120 volts and 125 volts in Article 210 is a testament to this adaptability. It demonstrates the NEC willingness to accommodate a range of voltage levels and to provide guidance that is both practical and forward-looking. In summary, the use of both 120 volts and 125 volts in Article 210 of the NEC is not a mistake or an oversight. It's a deliberate choice that reflects historical practices, acknowledges the tolerance of electrical equipment, and provides a degree of future-proofing for electrical installations. The dual voltage reference does not create loopholes or diminish safety. Instead, it represents a pragmatic approach that balances historical considerations, practical realities, and future possibilities. Electricians, engineers, and anyone involved in electrical work should understand the rationale behind these voltage references and how to apply them correctly in their designs and installations. By doing so, they can ensure that electrical systems are safe, compliant, and adaptable to the evolving needs of the industry. Let's delve a bit deeper into the specific sections of Article 210 that mention 120 volts and 125 volts. And explore the context in which these voltage levels are used. As we've already mentioned, Section 210.6 of the 2014 NEC specifies 120 volts as the nominal voltage for branch circuits that supply lighting and receptacle outlets in dwellings. This section is primarily concerned with ensuring that the voltage supplied to these common household loads is within a safe and acceptable range. By specifying 120 volts, the NEC aims to provide a consistent and reliable power supply for everyday appliances and lighting fixtures. On the other hand, Section 210.8 refers to 125 volts, nominal, in the context of ground fault circuit interrupter, or GFCI, protection for personnel. This section requires GFCI protection for certain types of outlets and equipment that are located in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. The use of 125 volts in this section is not intended to indicate a different voltage level than 120 volts. Instead, it's meant to acknowledge that the actual voltage at these outlets may vary slightly due to factors such as line losses and voltage drops. By specifying 125 volts, the NEC ensures that the GFCI protection is effective even if the voltage is slightly higher than the nominal value. It's important to note that the 125 volts referenced in section 210.8 does not mean that electricians should intentionally supply 125 volts to these outlets. The nominal voltage should still be 120 volts, but the GFCI protection should be designed to function properly even if the voltage fluctuates slightly above this level. In addition to sections 210.6 and 210.8a, there may be other sections of Article 210 that refer to either 120 volts or 125 volts. It's essential to consult the specific edition of the NEC that applies to your jurisdiction and to carefully review the context in which these voltage levels are used. The NEC is a complex and comprehensive document, and it's crucial to have a thorough understanding of its provisions in order to ensure safe and compliant electrical installations. One way to gain a deeper understanding of the NEC is to attend training courses and workshops offered by reputable organizations such as the National Fire Protection Association, or NFPA, and the International Association of Electrical Inspectors, or IE. These courses can provide valuable insights into the NEC requirements and help you to stay up to date with the latest changes and interpretations. Another helpful resource is the NEC Handbook, which provides detailed explanations and examples of the code's provisions. The handbook can be a valuable tool for understanding the intent behind the code and for applying it correctly in real-world situations. In addition to these resources, it's always a good idea to consult with experienced electricians and electrical engineers who have a thorough understanding of the NEC. They can provide valuable guidance and insights based on their practical experience. When working with electrical systems, safety should always be your top priority. Always follow the NEC requirements and best practices, and never take shortcuts or compromise on safety. Electrical work can be dangerous, and it's essential to be properly trained and qualified before attempting any electrical tasks. In conclusion, the use of both 120 volts and 125 volts in Article 210 of the NEC is not a cause for concern or confusion. It's a deliberate choice that reflects historical practices, acknowledges the tolerance of electrical equipment, and provides a degree of future-proofing for electrical installations. By understanding the rationale behind these voltage references and how to apply them correctly, electricians, engineers, and anyone involved in electrical work can ensure that electrical systems are safe, compliant, and adaptable to the evolving needs of the industry. Remember to always consult the latest edition of the NEC and to seek guidance from qualified professionals when needed. Safety should always be your top priority when working with electrical systems. The National Electrical Code is not just a set of rules, it is a living document that reflects the best practices and knowledge of the electrical industry. It's designed to protect people and property from the hazards of electricity, and it's essential to follow its requirements diligently. As technology continues to advance and new electrical devices and systems emerge, the NEC will continue to evolve and adapt. It's important to stay informed about these changes and to update your knowledge and skills accordingly. By doing so, you can help to ensure that electrical systems are safe, efficient, and reliable for years to come. So, the next time you encounter a reference to 120 volts or 125 volts in the NEC, remember the historical context, the practical considerations, and the future possibilities. Understand that these voltage levels are not arbitrary or inconsistent, but rather reflect a deliberate and well-reasoned approach to electrical safety and design. And always remember that safety should be your top priority when working with electrical systems. Electricity is a powerful force, and it should be treated with respect and caution. By following the NEC requirements and best practices, you can help to protect yourself and others from the hazards of electricity. I hope this explanation has been helpful in clarifying the reasons behind the use of both 120 volts and 125 volts in Article 210 of the National Electrical Code. Remember to always consult the latest edition of the NEC and to seek guidance from qualified professionals when needed. The NEC is a complex and comprehensive document, and it's essential to have a thorough understanding of its provisions in order to ensure safe and compliant electrical installations. And always remember that safety should be your top priority when working with electrical systems.